there is a generation of the impulse. It shows the property of automaticity. And if you check the rhythm, that is the distance between the two contractions, is equal, means the rhythm is equal. The same events occurs at a regular interval of time, that is called as rhythm. Means it possesses the two property. In a simple word, we are saying that auto-rhythmicity. Automaticity is different and rhythmicity is different, but the single word is auto-rhythmicity. So the first property you have seen in the practical case, you have seen auto-rhythmicity, then conductivity, and as you know that when this impulse reaches up to the muscle, it shows the response, that is called as excitability. It's clear that it shows the property of excitability. Then after excitation, it shows the contraction, that is a contractility. So such property are seen by applying the Stein's ligature in the first part. In the second part, we are going to discuss about the all or none law. What is this all and none law? For that purpose, you should know about the structure of the cardiac muscle. As you know that in case of the skeletal muscle, we have seen that a motor unit is there. A skeletal muscle possesses a lot of motor units, and these motor units again depends upon the size of the motor units. How many motor units is nothing but a single motor neuron end of the fiber of the motor neuron, which will supply to the number of the muscle fibers, and together they are called as a motor unit. Is it clear? In case of the skeletal muscle, motor units again varies depending upon the number of the fibers. In skeletal muscle, it contains the mixed type of the fibers. Some motor units contains the fiber which has a less diameter. Some motor units has the fiber which contains those fibers have a large diameter. Now, for the stimulation of the motor units, such types of the motor units are there. If you want to stimulate these motor units, then the strength of the current required for the stimulation of the various motor unit is different. So, in skeletal muscle, single motor unit obeys the all or none law. All and none law means what? Means that if you stimulate the particular motor unit, the specific strength of the stimuli, and if the strength of the stimuli is a threshold strength of stimuli, then muscle shows the response. This is a all phenomenon, or this is a response from the muscle. If you decrease the strength of stimuli, muscle does not show the response. That is called as a none phenomenon. Is it clear? And now, if we are going to check whatever the muscle unit has given the response, that is a all muscle or the all phenomena. Again, we are going to increase the strength of the stimulus. Means that there is no increase in the magnitude of the height of contraction. Again, we are going to increase the strength of the stimulus, no increase in the height of contraction. Means it indicates that at a specific threshold strength of the stimulus, all muscles contract simultaneously. This is called as an all phenomena. And this all phenomena is better demonstrated in case of the cardiac muscle. As you know that the cardiac muscles are arranged in a such way, they are interconnected with each other. Means that ventricle part, atria, and the sinus venous. In case of the cow, while in case of the human, atria and the ventricle. Ventricle is a single unit, atria is a single. Again, it depends upon the innervation of the conducting system. Again, it varies. Means that if you stimulate this cardiac muscle arranged in a cell-cycling structures, each cell connected to the other cell by the intercalated disc, and this intercalated disc will work as it will provide the path for the transmission of the impulse. Is it clear? So, if you stimulate any part of the cardiac muscle or any part of the ventricle, whole ventricle will contract. There is no local contraction of the cardiac muscle. So, when there is a stimulation, whole ventricle will contract. Means that whole ventricle will show the response to a specific strength of the stimuli, and that we are going to discuss what is a all phenomena and what is a none phenomena. So, for that purpose, as you know that we are going to tie a first Stein's ligature. We are going to tie a first Stein's ligature. Then we will discuss about the arrangement of the instrument. We will keep this kind of out of the circuit. then we will keep the distance between the primary and the secondary coil maximum up to the 30 centimeter or more than, and slightly slowly we will increase the working distance. And for that purpose, the instrument requires a pyrograph, micrograph board with a stand and the starting point lever, then the movable electrode, then this tab key. This is again the EMDM, electromagnetic time marker, and this is a induction coil. Is it clear? Now, as we are saying that we are going to tie the first sinus ligature, then we keep this prepared. We will mount this hard preparation on the micrograph board. We'll pass the pin at the apex of the heart. We'll take the precaution that should not puncture of the ventricle. Then if you tie this thread to the apex of the heart shows the contraction. Then what will happen when the contraction, there is a lever is there. For example, this is a lever and we have tied a thread to the lever and there is a pin in this form, and if you tie this pin to the ventricle and ventricle will contract, what will happen to the movement of the lever? Lever will goes down. Means that during the contraction of the ventricle or the heart, lever will goes down. Is it clear? So means the downstroke is systole. Downstroke is systole or the contraction, and the upstroke is that. Here I am not showing the contraction of the sinus venosus as well as the atria, because we have tied the thread at the junction of the sinus venosus and atria. So we are observing only the effects of the ventricle, and those effects we are observing by the stimulation. Because after tying the first sinus ligature, the time required again for the generation of the impulse, and we are performing this experiment during that time. Is it clear? So you have to complete your experiment before the idioventricular rhythm. Is it clear? Before starting the idioventricular rhythm. So for that purpose, what we will do, as we have seen in case of the cardiac muscle, skeletal muscle, first we have understood what is the downstroke. Downstroke means the systole of the heart. So what we do, first we will this is actually distance between the primary and the secondary coil. First we will keep the distance maximum, and with the help of this immovable electrode, just we are going to stimulate the ventricle. Is it clear? At this distance, we have not got the response, so the straight line will be required. Is it clear? Then again we will decrease the distance, and we are going to adjust the tap key in such a way so as to get the make as well as the break. Is it clear? And if you know that, in concern of the strength of the stimulus provided by the brake shock is always greater as compared to the make. That we have discussed. We are not going to discuss in detail about this again. Okay? Then this straight line will be recorded. Then we will get a time, and there will be the electromagnetic time marking. Is it clear? So we will get the time where we will get the brake shock. So this will be the make. This will be the make shock. This will be the brake. At this point, we will get the response from the cardiac muscle. In this form. So this response we have got at a brake, because brake is a stronger stimulus. Is it clear? Then, if you again decrease the distance between the primary and the secondary coil, again, now at this point, we have got the response at make. This will be the break. Again, we will decrease the distance between the primary and the secondary coil so as to increase the strength of the current. So then there will be the make. Again, there will be the response from the cardiac muscle in the form of the contraction and the relaxation. This will be the make stimulus. Then at break, there will be the again response from the cardiac muscle. What it indicates, previously what you have done, we have kept the distance between the primary and the secondary coil at a maximum where the strength of the stimulus is minimal, that is sub-threshold. So we can say that in this portion, whatever the current we have delivered, this will be the make, this will be the break, this will be the make, this will be the break, and in this way, make, break, make, and break. So this distance means that whatever the strength we have delivered during this period, those are sub-threshold stimulus. Those are the sub-threshold stimulus from this side in this portion. Beyond that, we achieve the strength of the stimulus which is sufficient to generate the response from the muscle, and that is nothing but this break. We have got the response first at the break because break shock is always stronger than the make, and beyond that we have got the response at the make as well as the break, and it shows that there is no change in the height of contraction. There is no change in the height of contraction. Is it clear? Understood? It indicates that at this part showed no response because the strength of the stimulus is less, not sufficient. Heart doesn't show response to the minimal strength of the stimulus or the sub-threshold of the strength of the stimulus. That phenomenon is called as a null phenomenon. That is called as a null phenomenon, which is at sub-threshold. Understood this? Now, when the break shock we have given to the heart or the cardiac muscle, it gives the response. But though the strength of the stimulus, there is a difference in the strength of the stimulus in the make as well as the break. Height of contraction in the break as well as in the make, in the break as well as in the make, is the same. Is same. There is no difference in the height of contraction. Means when the strength of the stimulus reaches up to the cardiac muscle shows the whole its activity, the whole response, that is called as the Hall phenomenon. Hall phenomenon, and it appears as a threshold and on a supra threshold. Understood? What is the all phenomena? What is a non-phenomena? Is it clear? The better example is fan without regulator. स्विच ऑन करते हैं तो पूरा रोटेट होता है. इज इट क्लियर? स्विच ऑफ है, नॉन फेनोमेना है, ऑन करते हैं मैक्सिमली रोटेट. दैट इज अ ऑल फेनोमेना. इज इट क्लियर? And this is the most important phenomena because if you compare to the cardiac skeletal muscle, if you compare to the skeletal muscle, as we have seen that effect of the various strength of stimuli on the skeletal muscle, what we have observed, some part of the skeletal muscle gets stimulated at a threshold. As you increase the strength of the stimuli, number of the motor unit take parts, increase the number of the motor unit in the activation of the skeletal muscle, and finally we will get all motor units get participate. Is it clear? But if it is happen concerning with the cardiac muscle, suppose this is a ventricle of the heart, some part of the ventricle will contract at a threshold stimulus. If you again increase the strength of the stimulus, again number of the cardiac muscle take part into the contraction. And if such case is there, it is impossible to undergo the full systole and it is impossible to eject the blood into the aorta. And it is avoided by obeying the all and none law. In case of the cardiac muscle, whole heart obeys the all and none law. In case of the skeletal muscle, only single unit or the motor units obeys the all and none law. Single motor units obeys the all and none law. Now understood about this? What is the all and none law? Okay, the most important thing concerned with this practical, we are going to stimulate the cardiac muscle. But what happens when there is a stimulation? As you know, there is a transmission or there will be the entry of the calcium into the cardiac muscle. Then there will be the binding of this protein C. Sorry, this calcium. There will be the opening of the active sites. And then there will be the binding of this active myosin brake will form and the contraction will occur. This increases the amount of the calcium is remain as it is for up to the 30 seconds. Is it clear? If you apply the second stimulus before the 30 seconds, then previously increase the concentration of the calcium. Again, if you are applying the second stimulus, again there is increase in the amount of the calcium. More and more active sites will be open as compared to the first stimulus. So it is avoided in this practical by applying the second strength of the stimulus after the 30 seconds. Have understood? Have understood? We have avoided here the beneficial effect. We have avoided here the beneficial effect by applying the second stimulus after the 30 seconds. Have understood? Means that I have tapped this key, I have completed this subject, then I have waited for about 30 seconds or more than the 30 seconds, then I have applied the brake shock. Have understood? So this is about the all and none law. That is the first property of the cardiac muscle. Means in the second property, that is the properties of the cardiac muscle 2. In that there is this is a all and none. Now we discuss about the next practical. That is the long refractory period. Cardiac muscle properties 3. Long refractory period. In this practical, we are not going to tie the stannous ligature. Just there will be the recording of the sinus venosus artery as well as the ventricle. Long refractory period. We have studied the refractory period in case of the skeletal muscle also. We have compared at that time this is long refractory period is more in case of the titanus practical, genesis of the titanus. We have seen the cardiac muscle possesses the long refractory period. This long refractory period is up to the 250 to 300 milliseconds. While in case of the cardiac muscle is very less. Sorry, in case of the skeletal muscle it is very less. Then how will study this long refractory period in case of the cardiac muscle? So for that purpose, we are going to use the same instruments. Difference is we are not going to tie the stannous ligature to the at the junction of the sinus venosus and the artery. Then here we will start the recording. First, we'll record the normal cardiogram. This normal cardiogram will be in this form. This is a normal cardiogram. Now, here we have to achieve a technique. You have to deliver a stimulus. So for that purpose, you should know the. Suppose this is a one phase of the normal cardiogram. This is a systolic phase. This is a diastolic phase. This is actually mid diastole. This is actually late diastole. This will be the end of diastole.
मग येणार नाही का तात्या आता?
And this is the early diastole. And before that, there is a end of systole. If we compare this long refractory period to these phases, this long refractory period means it again possesses the two parts, that is absolute refractory period and relative refractory period. Refractory period means that the strength of the stimulus, whatever may be the strength of the stimulus, maybe the suprathreshold, previously excited tissue does not show the response. Is it clear? But the strength of the stimulus should be more. Again, it has two types: relative refractory and absolute refractory. The absolute refractory period is the period during which we can't stimulate the already excited tissue when the strength of the stimulus is a suprathreshold, though the strength of the stimulus is suprathreshold. In relative refractory period, the period during which if the strength of the stimulus is suprathreshold, already excited tissue can give the response. This is the period, that period we are going to call as a relative refractory. In case of cardiac muscle, this whole systole shows the absolute refractory period. Whole systole is the whatever the period required for the systole, whole period is absolute refractory. Is it clear? While in case of diastole, whole diastole is relative refractory. Whole diastole is relative refractory. But it is said that from 1/3 part of the diastole is only relative refractory. Practically, we can't say in such a way. Practically, diastole is a full refractory. That we are going to discuss. Is it clear? That we are going to discuss. Now, so for that purpose, if you apply the strength of the first criteria, strength of the stimulus should be more than the threshold. That is, the strength of the stimulus first is a suprathreshold. So what we will do in this experiment, we will achieve the strength of the stimulus, whatever we have recorded this normal cardiogram, by keeping a distance between the primary and the secondary coil at the threshold level. First, we will increase the distance between the primary and the secondary coil so as to get the suprathreshold strength of the stimulus. As you have seen, there are the phases. Contraction phase is there, relaxation phase is there, again contraction phase is there.
घट होऊन बसते लगेच बाहेर आले की रुचिकावणी पांढर होते.
Now we have to achieve a technique. You have to deliver the stimulus during at the end of the relaxation, at the mid relaxation, at the start of the relaxation, and during the systole. And you have to observe that now there is a beating of the heart. We are recording on the timograph. With the help of the tab key, we have to complete the circuit at these different phases. We have discussed these different phases. Is it clear? So first we will apply this strength of the stimulus, suprathreshold strength of the stimulus at the end of the systole. So what we are expecting? What we are expecting here, if the strength of the suprathreshold stimulus is applied at at the initial part of the diastole. Heart shows the response, cardiac muscle shows the response or will not going to show the response. Whole related refractory period is, whole diastole is a refractory period. You are expecting the response. Is it clear? Now the contraction stage is there. Second stimulus fall at the early relaxation or just at the end of the systole. Again calcium increase. Again concentration of the calcium get increased. Then same contraction will continue. That same contraction continue. That called as a contraction of the muscle is a systole. Again we are stimulating. We are again stimulating. It again shows the contraction, but this is an extra contraction shown by the cardiac muscle due to the application of the artificial strength of the artificial stimuli, which is the supra threshold. It shows the extra contraction. That is nothing but it shows the extra systole. It shows the extra systole. So that now we will record what happens if the strength of the stimulus is applied at the end of the systole, then it shows the extra systole. So it will show the extra systole in this form. For your understanding, just I will mark in this position only. I got? Then, if you observe the first graph in the ECG, if you observe what happens actually. This is actually contraction phase. Is it clear? Systole is there. Then again diastole is there. At this phase, there is an application of the stimulus by the sinus venosus. So the first sinus venosus undergoes the contraction, undergoes the relaxation. Atria will contract, atria will relax. Then this ventricle, this stimuli will reaches up to the ventricle. Ventricle shows the contraction, ventricle again shows the relaxation. Means that there is a generation of the stimuli or the impulse at a regular interval time, and it shows the contraction by the sinus venosus, relaxation by the sinus venosus. Then atria will contract, atria will relax. This ventricle will contract, ventricle will relax rhythmically. When we say rhythmically, distance between the two contractions is equal. Conduction of the impulse at a same interval, at the same rate. So the distance between the two successive contraction is equal. That's why it's called as the atorhythmicity. Why I am emphasizing this point? Because what happens at this level? Your graph should be in this form. If you not going to apply
त्या संध्याकाळी 4 वाजता गोळा करतो मी.
Your graph should be in this form. Is it clear? When the second stimulus will apply on the after the relaxation phase, but we have applied the artificial stimulus. What happens during this period? Whatever the stimulus, natural stimulus, going to apply after relaxation, it get applied in the extrasystole phase. It get applied in this extrasystole phase. Is it clear? And as you know that systole is absolute refractory. Systole is absolute refractory. Is it clear? So though in the extrasystole phase, natural impulse will be there. It will appear during the extrasystole. So it is ineffective. Is it clear? Now what will happen? Now, whatever the extrasystole we have seen, this extrasystole we have seen, by applying this extrasystole, we have disturbed the rhythmical transmission of the impulse. Is it clear? Now, again it shows the diastole. It shows the diastole. as and at this level, drum is rotating. Is it clear? So this marking will be there. Is it clear? And means that at this portion, cardiac muscle, waiting for the natural impulse. Is it clear? When the natural impulse will appear, cardiac muscle again shows the contraction in this form. Is it clear? Have you understood? Why whatever the stimulus natural stimulus falls during the extrasystole, it is ineffective because systolic phase is absolute refractory. Now, after completion of this extrasystole, heart and cardiac muscle undergoes the diastole. At the end of the diastole, cardiac muscle waiting for the next natural impulse. Is it clear? It is waiting for the next natural impulse. Then what happens? Then the next natural impulse appears and cardiac muscle shows the response. In the form of the systole. It again shows the diastole. But you see the height of contraction. This is a normal cardiogram, that is the MC. Is it clear? But you see the height of contraction. The height of contraction is more. What happens? What is the reason behind this? Which will show this maximum height of contraction. We have seen this event. Is it clear? Now the phase starts from actually this part. Now the heart is in a diastole, waiting for the next impulse. But the period required for the receiving the next natural impulse is more. Understood? Is more. If you compare this, the period required for the natural so as to get the natural impulse is more. During this, what happens? There is a diastole. Excess amount of the blood comes into the ventricle. Is it clear? Excess amount of the blood come into the ventricle. If the excess amount of the blood is there in the ventricle, according to the Planck-Starling law, what will happen to the initial length of the cardiac muscle fiber? Initial length of the muscle fiber gets increase. Initial length of the cardiac muscle gets increase. As a result, what we are expecting concerning with the cardiac output? Cardiac output will increase. So for that purpose, this height of contraction after receiving of the next natural impulse is more. Is it clear? Actually, this portion I have shown is a maximum length I have shown for your understanding purpose. Is it clear? ये इतना वेट नहीं करेगा. मतलब यहाँ इतना NCG लिया है, यहाँ आपने एक्स्ट्रा सिस्टम मिला है आपको, ऐसे ऊपर जाएगा, इमीडिएटली यहाँ पॉज रहेगा, उसके आगे इमीडिएटली कॉन्ट्रैक्शन रहेगा, और उसके आगे फिर नेचुरल इंपल्स, यहाँ नेचुरल इंपल्स अचीव करने के बाद इतना रहेगा. So I have shown this response, this record for your understanding purpose. Is it clear? So we have studied this property of the long refractory period. Have understood? So we have studied this property by applying this stimulus fall, second natural impulse fall during the extrasystole. So this will be labeled as a extrasystole. This is the extrasystole. Extrasystole, after extrasystole, there is a pause taken by the ventricle so as to receive the natural impulse. That pause is called as a and this pause is taken so as to compensate the natural rhythm of the heart. So it is called as a compensatory pause, and this is a increase height of contraction. This increased height of contraction is due to the Frank-Starling law. Understood? Yes or no? Okay. How it is a beneficial to the heart? This long refractory period is a beneficial to the heart. How? Though we have disturbed the natural impulse transmission, heart take the pause and it wait for the next natural impulse and then shows the again natural rhythm. Is it clear? So this is a property shown by the cardiac muscle, that is a extrasystole and compensatory pause. Is it clear? This property we can state it with the help of the another graph, that is a two successive stimuli. The first graph we have seen, you should know the phases. Now, for this purpose, the instrument arrangement will be, as we are going to apply the two successive stimuli. First thing, how to apply the two successive stimuli? So, in the skeletal muscle, we have applied the two successive stimuli with the help of the kymograph. And the main components of the kymograph are these two strikers. First, we will adjust the distance between the two strikers in such a way that first we have seen that this systole and diastole of the heart. Here, so this is the end of the systole. Sorry, end of the diastole. First, we will adjust the distance between the two strikers in such a way that first impulse is fall, due to that this contraction is there, this relaxation. Is it clear? Now we are going to adjust the distance between the striker in such a way second stimulus fall at the end of relaxation. At the end of relaxation. Is it clear? So this will be the first. Then we will again arrange, or we will again decrease the distance between the two strikers. So what will happen? The next stimulus fall immediately, and we will adjust this distance which will stimulate the cardiac muscle during the mid relaxation. Again, we will adjust the distance between the two strikers. Again, we will decrease the distance. So the stimulus will fall at the early relaxation. And finally, again we will arrange, or we will adjust the distance between the two strikers. Again, we will decrease the distance between the two strikers, which will fall the second stimulus at the end of, or during the end of the systole. ये डायग्राम इंपॉर्टेंट है. ये सिस्टोल है, ये सिस्टोल है पूरा, ये है डायस्टोल. These are the stages of diastole. You should know about this. And it is due to the, how will apply the second stimulus by adjusting the distance between the two strikers. Only difference is there. Is it clear? Now in this, we are going to again apply the first anesthesia. Is it clear? Here we are going to again take this EMBM into the circuit so as to show the point of stimulation. So as the ventricle contracts, this is a application of the stimulus of the first slide. Is it clear? Then here the stimulus applied at the end of relaxation. So there is a no change in the height of contraction of the ventricle. Is it clear? Then again, so the EMTM will be in such a way. Here again we are going to apply the second stimulus at the end of the stone. So it shows a little more contraction. समझ में आ रहा है नहीं? Again, during the mid relaxation. So what will happen? From this point again, contraction will start. A height of contraction will be more. Can you tell me the molecular mechanism of this? Molecular mechanism. First, see what happens to the if you deliver the first stimulus to the tissue for the contraction purpose. In case of the cardiac muscle we are discussing, there will be the entry of the calcium from the ECF into the myocardium. Because sarcotubular system it is not well developed in the cardiac muscle as well as in the smooth muscle. Is it clear? But it is highly developed in case of the skeletal muscle only. Now, what happens if you deliver the first stimulus? Calcium enters into the sarcoplasm. Calcium concentration is increased. Now we are going to discuss about the next one. Now, here whatever the number of the calcium ions are there, they will open the active sites. Suppose in the first there is a X concentration of the calcium ions are there in the sarcoplasm. Now what happens after completion of the contraction? Muscle is going to start the relaxation. In the relaxation process, there should be a pumping of the calcium from the sarcoplasm into the sarcoplasmic reticulum or sarcotubular system and exit of the calcium to the tissue. Is it clear? And when there is a decrease in the calcium concentration or whatever the calcium concentration increase due to the first stimulus, and at the end of the relaxation, again that increases concentration of the calcium brought to the normal level. So we can label in this way, means that this is the normal concentration of the calcium in the sarcoplasm, and due to the stimulation, this concentration increases up to the A. Is it clear? And again it is brought to the normal level. Understood? But this stimulus is delivered during the relaxation process. Relaxation is not completed. Is it clear? Whatever the concentration is there in the form of A, it is not completely removed to the normal level. We can say that means that this is a fraction of the calcium which is come back and brought to the normal level to the first contraction and relaxation. We apply those kind of the stimulus at the mid relaxation. So this amount of the calcium is available for the next contraction. This excess calcium is available, and this is the beneficial. So as to increase the again concentration of the calcium. So the concentration inside the sarcoplasm is plus this, मतलब नॉर्मल से A तक है और प्लस ये. समझ में आ गया? So this increase the calcium concentration is there. Increase the amount of the calcium into the sarcoplasm, more and more active sites will be open, and then force of contraction will be more. So for that purpose, in this case, whatever is shown, it is actually showing the whatever the concentration is there. ये concentration बढ़ गया है यहाँ. So height of contraction in the second stimulus is always more. Is it clear? And you have to show this is the effect of the first stimulus. This is the effect of the second stimulus. Understood? Then the second stimulus fall just at the start of the relaxation. Second stimulus fall just at the start of the relaxation. Then immediately there will be the contraction and relaxation. Again, excess amount of the calcium is available. Is it clear? Which will open the again more and more active sites. In this way, it shows the contraction. So this is the effect of the first stimulus, and this is the effect of the second stimulus. Then now the next stimulus going to fall during the at the end of systole. At the end of systole. So what happens? Heart does not show the response. Does not show the response because it falls during the absolute refractory period. It falls during the absolute refractory period. So I have understood about the long refractory period again. Long refractory period means that it is divided first into the absolute and relative refractory. Each and every event is concerned with the absolute refractory period and relative refractory period. In the first case, it shows both the absolute as well as the relative refractory period. Second stimulus fall at the end of the relaxation, where the natural impulse actually falls. Is it clear? So no increase in the height of contraction. Why there is an increase in the height of contraction, that we discussed at the molecular level. In case of the second, here the second impulse falls, but just at the end of the relaxation. So slight increase in the height of contraction. Then the second stimulus falls at the mid relaxation period. Is it clear? So again increase in the height of contraction. The next stimulus fall at the initial phase of the relaxation, which is a relative refractory period, and shows the heart shows the contraction again in the form of the extrasystole. Here the stimulus fall at the end of the systole, which is actually absolute refractory period. Understood? So label this as this is the first, where the stimulus falls at the end of the relaxation. This is the stimulus fall at the, we label this in such a way. So the first will be the stimulus fall at the end of relaxation. After the end of relaxation, actually, after the end of relaxation. In this case, second stimulus fall at the end of relaxation. End of relaxation. Then in the third case, mid relaxation. The fourth case, start of initial phase of the relaxation. And in the fifth phase, stimulus fall end of system. The same phenomena we are going to apply for the cardiac muscle when we are going to discuss the ECG. In some cases, what happens actually, such type of the extra bit is there. That extra bit is nothing but this extra systole. Again, there is a pause. There is no problem because the heart again achieve in the next phase, heart again achieve the normal rhythm by taking the pause in the form of the compensatory pause. You understood this? Then the next part is incomplete tetanus. What is the tetanus actually? Tetanus means what? In case of the skeletal muscle, we have seen tetanus. If you increase the frequency of the stimuli, then what happens? Muscle doesn't show the relaxation phase. It undergoes the continued contraction. That's nothing but the tetanus. We have discussed about again the clinical tetanus. We are not going to go in further detail. Just we will discuss about the incomplete tetanus. But what happens in case of the cardiac muscle? This tetanus is a possible in case of the skeletal muscle only. Why? Because this absolute refractory period shown by the skeletal muscle is a very short, and relative refractory period is more. But the reverse condition is there in case of the cardiac muscle. Cardiac muscle possesses the long refractory period, and that's why we can't tetanize the cardiac muscle. So it shows the incomplete tetanus. It shows the incomplete tetanus. Then, so for that purpose, we are going to stimulate the cardiac muscle continuously for a longer period of time. But this cardiac muscle doesn't undergo the tetanus. Suppose this again we have performed in a ligated heart. First anesthesia we are going to apply. Then we are going to stimulate only the ventricle for a longer period of time. Then you stimulate this, then the cardiac muscle shows the contraction. Okay, it shows the contraction again. The next stimulus pause. So the contraction and relaxation. It shows the contraction and relaxation, and this leads to the EFTM marking. We have applied the continuous stimulation. We can't tetanize the cardiac muscle completely because it possesses the long refractory period. Whatever the stimulus called during the systole is ineffective. So this is only about the incomplete tetanus. Then the next practical, that is a beneficial pain. method itself is the information beneficial. Now, as you have seen that, while application of the stimulus, we are going to consider the time. To want to record the normal cardiogram shows the beneficial. Whatever the stimulus we are going to apply in the normal cardiogram, it is applied. One stimulus is second stimulus is applied. The distance between the two stimulus is less than the 30 seconds. Is it clear? Then what happens between these 30 seconds? Or why should not be there? Why, whatever the strength of stimulus, whatever the stimulus we are going to apply after the end of the relaxation, what happens actually between this? Then see that application of the first stimulus, entry of the calcium will be there, contraction will occur. After the completion of the contraction, relaxation process is there, during which the whatever the excess calcium is there in the sarcoplasm get come back into the ECF as well as into the sarcoplasmic reticulum. But if you apply the second stimulus before pumping of this calcium into the sarcoplasm or into the sarcoplasmic reticulum, then first stimulus, whatever the excess calcium is there, during the relaxation process, whatever the calcium remains for pumping of this calcium into the sarcoplasm, into the ECF. Meanwhile, before that, the second stimulus comes. Again, the second stimulus, whatever the excess calcium stored by the first stimulus, and again, whatever the excess calcium stored by the third stimulus. Again, if you apply the third stimulus, again excess calcium. So in this way, the calcium concentration get increased to open the maximum active sites, and there will be the first, whatever the first height of contraction we have got, it is a less to the as compared to the second. Means why I want to say that the what height of contraction achieved by the second stimulus is greater than the first. Whatever achieved by the third stimulus is greater than the second. And whatever achieved by the fourth, it is a slight greater than the fourth, greater than the third. But what happens after the fourth and fifth stimulation? As you know that whatever the active sites are there, so all active sites get open. Then there should be a specific height of contraction. Beyond that, there will be no increase in the height of contraction. But in the first part, what are the reasons behind this? First is the increase in the excess calcium concentration. Second, there is a resistance for the transmission of the impulse at the level of the neuromuscular junction, at the level of the muscle, for the development of the action potential, at the level of the neuron, at the level of the release of the calcium from the sarcoplasm, from the ECF into the sarcoplasm, or from the stored in the form of the endoplasmic reticulum or in the form of the sarcoplasmic reticulum. Then again there is a required time, and if it is a whatever first stimulus fall, it will open all these activity. Again there is an increase in the temperature. Increase in the temperature again increases the enzymatic activity for the second stimulus, third as well as the fourth stimulus. Is it clear? So, in a such a way, all these factors which will increase responsible for increase in the height of contraction for the second, third, and the fourth. After that, there is all active sites get open. Now the calcium is excess, but the active sites are open. All active sites are open. No, the active sites are remaining for the opening, though the excess calcium is there. Though higher increase in the temperature, all enzymes get activated. Means that these factors has a certain limit. If the excess calcium is there or increase in the enzymatic activity, all these factors has a limit, So we'll get the increase in the height of contraction in the successive stimulation, and after that the height of contraction will be constant. Is it clear? So that we are going to record. So how will we achieve this? By applying the first stimulus, then second, divide that the height of contraction is maintained. Here at this level, what happens actually? All enzymes get activated. Increased temperature is responsible for this. Again, all active sites get open at this level. But this first stimulus increases the calcium concentration. Again, it increases the temperature. Again, it increases the enzymatic activity, which are favorable for the second. So the height of contraction of the second stimulus is more, and the second is beneficial to the third. Third is beneficial to the fourth, and at the fifth, again there is an increase in the height of contraction as compared to the first four. Divide that, whatever the enzymes are there which are responsible for the contraction purpose, whatever the excess calcium is there which are going to be responsible for the opening of the active sites. All active sites are open. No active site will remain for the opening of the opening, though there is increase in the calcium concentration. So in this way, it shows the staircase effect. It shows the staircase effect. Staircase means staircase effect. This staircase effect is due to the beneficial phenomenon. It is due to the beneficial phenomenon. But the confusion is that though we are going to call as a beneficial effect, it is okay. Though we are going to call as a staircase effect, though it is. Physical form is staircase effect. Is it clear? But it is due to the phenomenon of beneficial, or it is due to the beneficial. Understood? Whatever we will label, we are going to label as for the appearance, no problem. If there is a labeling for the due to the phenomena, no problem. Is it clear? Understood about this beneficial effect? What important is you apply the second stimulus before the completion of the 30 seconds. What happens in the 30 seconds? If you apply the first stimulus in the 30 seconds, contraction will be there, relaxation will be there. In the relaxation process, whatever the excess calcium is there, it will be pumped out into the ECM. All enzymatic activity rate get down because decrease the temperature. So you have to, if you want to get this beneficial effect, you have to apply the strength of the stimulus at the rate of 3 to 5 seconds. Keep in mind, this is the most important. This is the most important. You have to apply the strength of the stimulus, successive strength of the stimulus at an interval of 3 to 5 seconds. And so as to avoid the beneficial effect, you have to apply the strength of stimulus more than the 30 seconds. Is it clear? Have you understood about this? Now, whatever graph we have discussed on the board, you have to draw the same graph on a plain paper, and you have to suppose there is an ideal graph in your journal at this position, at this location. This is suppose this is your page. Okay, you have to draw this graph on a plain paper. So suppose this graph is there, ideal graph is there in your journal. You have to draw this graph on a plain paper, which will it has a fill. You have to draw, you have to apply this, you have to paste this page at this location. Why? You have to compare this graph, whatever you have drawn. You have to compare this graph with this graph. Is it clear? For the comparison purpose. Suppose two ideal graphs are there in your journal. Then what you have to do? You have to draw this graph on a full plain paper, and you have to draw this ideal graph or whatever the draw on the board, and you have to draw this graph on this paper. Draw this graph. सेपरेट कर रहे हैं तो मतलब ऐसे कर रहे हैं कि ये प्लेन पेपर, ये इस पे जो ग्राफ है आपके, इस पे आपको ग्राफ ड्रॉ करना है, तो क्या करेंगे आप दो पेपर पे ग्राफ ड्रॉ करेंगे। इसका जो ग्राफ है नीचे पेस्ट करना है, इसका जो ग्राफ है इस पे पेस्ट करना है। इज इट क्लियर? मतलब अगर ये आप रिमूव करेंगे तो ये पेज आपका वैसे रहेगा, सो यू कैन कंपेयर। So in this way you have to draw this graph on a plain paper and attach the one side whatever we have discussed in this way. So this is about the completion of your journal. Just to summarize with the help of the PPT whatever we have discussed. Note down the questions. Slide change character, connect character. Switch it. Just we will repeat in the form. There is a properties of the cardiac muscle to all or none law that we have discussed. What is a all phenomena? What is a none phenomena? So we have to study about this the all phenomena and none phenomena issues about the we should know about the stimuli, that is threshold, sub threshold and supra threshold. We have discussed about this. This all or none phenomena is when the stimulus is adequate. That is the threshold. The tissue responds to its maximum. As you have seen that the whole atria of the whole ventricle contract, not there is a no local contraction is there. Means there is a no only apex of the ventricle will contract or the initial part of the ventricle will contract. Ventricle will contract as a whole at its maximum. Means that all phenomena. But it happens as a threshold. The tissue responds to its maximum, that is called as a Hall phenomena, and when the stimulus is inadequate, that is a sub-threshold. Tissue doesn't give any response. Tissue doesn't give any response, that is a none phenomena. Keep in mind, no response by the tissue, but it is at a sub-threshold. So you have to keep in mind the three things: stimulus in the sub-threshold form, tissue is there, does not give the response because stimulus is a sub-threshold, and that is called as a none. Means sub-threshold, non-response from the tissue, none phenomena. Supra-threshold stimulus, whole tissue will contract, whole tissue gives the response at its maximum, that is a all phenomena. Is it clear? Then about you have discussed about this graph. The question is, which property of the cardiac muscle is demonstrated in this record? ये ऊपर लेबल नहीं रहेगा, ये जो अंदर लेबल से ये भी नहीं रहेगा, ये खाली आपको ये contraction stage करके दिखा देगा. So you have to identify the graph. So the given graph is which property of the cardiac muscle is demonstrated in this graph. So the answer will be the all or none law. Then how is it achieved in cardiac muscle? What you have done for this? By applying the sub-threshold stimulus and threshold stimulus. It is achieved in the cardiac muscle by applying the sub-threshold stimulus and by applying the threshold stimulus. Now understood about this? So can you identify this graph? Keep in mind, Supra-threshold stimulus is there, sub-threshold stimulus is there. At a sub-threshold, no response, none phenomena. And there is no increase in the height of contraction, which indicates that though we are applying the supra-threshold strength of stimuli, here the threshold stimulus is there, which is not labeled, but here the supra-threshold stimulus has been given, and there is no increase in the height of contraction. Means previously, whatever the response given by the tissue at the threshold stimulus is maximum. So it is called as a Hall phenomenon. Then the properties of the cardiac muscle free, that is a long refractory period. We have discussed about this long refractory period. In case of the cardiac muscle, this long refractory period is about 250 to 300 milliseconds. The time interval during which the normal cardiac muscle or the impulse, normal cardiac impulse cannot re-excite the already excited tissue. The definition should be in a proper word. I have taken this definition from your journal, but your definition should be in a proper word. Cardiac impulse. As you are discussing regarding the cardiac muscle, we should tell about the cardiac impulse, which is then absolute refractory period, the period during which the cardiac muscle does not respond to any strength of the stimulus. That is this period is a whole systole. Then relative refractory period, the period during which the cardiac muscle respond to which stimulus? Supra-threshold stimulus. Is it clear? Then about the extrasystole. Extrasystole comes before the next normal impulse. Here it is called as a premature beat. Is it clear? Then the compensatory pause. The compensatory pause is the most important. What is the reason behind this? Why it is important to see? Next normal impulse from sinus venosus, pause during the extrasystole, and cardiac muscle is refractory during systole. So cardiac muscle does not give the response. Atria and the ventricle remain in a relaxed position till this remaining in a relaxed position means the compensatory pause. Okay, and they are waiting for till the next normal impulse arise from the sinus venosus in case of the frog. And this period of the inactivity is called as a compensatory pause, and it is helpful to maintain the normal rhythmicity of the heart. And when there is a normal maintaining of the normal rhythmicity of the heart, ultimately it is helpful to provide the blood, proper amount of the blood to the tissues. Is it clear? Then there is a Frank-Starling law. For what reason? In the diagram, after compensatory pause, ये heart of ये जो यहाँ diagram दिखा है, it should be more. मतलब इसका एक्स्ट्रा कॉन्ट्रैक्शन यहाँ आना चाहिए, वो नहीं दिखा है. Is it clear? यहाँ भी actually होना चाहिए, वो नहीं. What is this actually? A stimulus during the contraction. So no extra systole because stimulus during the contraction, stimulus is ineffective. No extra systole will be there. And in case of the B, stimulus fall at the end of the or in the early part of the relaxation phase. So there is a stimulus extrasystole noted here, and the C, that is a compensatory pause. In this graph, there should be a correction. After completion of the compensatory pause, the height of contraction is always more because excess blood is collected and is stated by this Frank-Starling law. Force of contraction is directly proportional to the initial length of the muscle fiber, but within a physiological limit, and it is a during compensatory pause, excess blood comes into the ventricle, length of the muscle fiber increases, which increases the magnitude of the contraction. In the examination, they will ask you, regarding this graph, why the height of contraction, though it is not shown here, why generally the height of contraction after compensatory pause is more. So you should know about the Frank-Starling law. You can say it is due to the Frank-Starling law. They again ask you, can you explain? So you have to explain in a such a way as due to the extrasystole, After extrasystole, there is a compensatory pause, heart wait, cardiac muscle waiting for the next impulse. During that period, excess amount of the blood collected into the ventricle. This excess amount of the blood increases the initial length of the muscle fiber. So there is a increase in the height of contraction. Have you understood? Then the question will be the identify the graph. What is the title of the graph? How will identify this graph? It's a graph of the extrasystole and compensatory pause in a cardiac muscle, which shows the long refractory period. You should know the basic property, that is a long refractory period. We are studying with the help of this, that is extrasystole and compensatory pause. We have studied this practically with the help of the three. First, we have the extrasystole and compensatory pause, and then discuss we will after this. What does B and C indicate? B indicates the extrasystole, C indicates the compensatory pause. B dash extrasystole, C dash compensatory pause. Is it clear? Then the two successive stimuli. The second stimulant falls during the absolute refractory period during systole of the first, hence second stimulus is ineffective. So which will be the effective? Stimulus fall during the relaxation period, during the diastole. So we will discuss about this. We have discussed about this. This is actually first, that is after relaxation. Second, late relaxation. Then third one is a mid relaxation. So the height of contraction in this graph is slightly more as compared to the first. Then at the early relaxation, there is a 4. The height of contraction should be more here. Then during the contraction. During the contraction, only single bit will be there because first stimulus fall. Is it clear? Due to the bit contraction of the heart is there, and during that the second stimulus fall. So in case of the fifth condition during contraction, second stimulus is ineffective. So in the examination they may ask you why there is no increase in the height of contraction in the fifth condition. Actually, whatever the effect is there, it is due to the effect of the first stimulation. And second stimulus fall, it is fall during the systole of the heart, and it is ineffective. So in this graph, only the contraction recorded. It is due to the stimulus. It is due to the first stimulation of the first stimulation. I understood about this. Then which property of the cardiac muscle is demonstrated in the first property is demonstrated करता है long refractory period. Basic है आपका long refractory period. Then next one is incomplete tetanus. Cardiac muscle cannot completely tetanize. It shows the incomplete tetanus because cardiac muscle possesses the long refractory period. Whole systole is absolute refractory. Because of incomplete tetanus, contraction is necessary followed by the relaxation, and in this way, circulation is maintained. This is the importance of the beneficiary. Is it clear? Sorry, incomplete tetanus. This is about the incomplete tetanus. Identify the graph, identify the record. Given graph is a beneficial effect which shows the long refractory period in case of the cardiac muscle. Which property of the cardiac muscle does it demonstrate? Long refractory period in cardiac muscle. There may be chances for the change of these questions. If there is a change, we will inform you along with your answers. Is it clear? Beneficial effect increases the force of contraction by successive stimuli due to the favorable condition produced by the previous contraction is called as a beneficial effect. And causes are the increase in temperature, decreases the viscosity of the cytoplasm and increases the enzymatic activity. Increase in the temperature, it has two effects. First is a decreases the viscosity of the cytoplasm, and second is a increase the enzymatic activity. And again, increase in the concentration of the calcium in cytoplasm. This is the graph of the beneficial effect. Identify the record. Then explain the property demonstrated in the graph. Which property is demonstrated? Beneficial effect. It shows the long refractory period in a cardiac muscle. In this way, we have completed our today's practical, that is a cardiac muscle properties 2, cardiac muscle properties 3, and beneficial effect. Beneficial effect is not under the long refractory period. Beneficial is a different property. So the long refractory period is shown by the extracellular compensatory pause, 2 successive stimuli, and incomplete tetanus. Is it clear? Don't confuse. Explain the property demonstrated in the graph. Beneficial effect. Explain बोला. इसके reasons क्या नहीं होता है? ये आंसर है. Explain बोला है. Actually, have you noted the questions? Yes. Yeah, आपकी में आएगा. Your question is explain. Actually, this is a question. These are the questions for the spotting purpose. So explanation will not. Because you have to complete your answers within a 1 or 2 lines only. 2 lines भी ज़्यादा होता है. वो explain में कुछ changes करने वाले हैं. तो इसलिए मैंने कहा है कि उसमें change होता है तो we will inform. Explain मतलब what is the beneficial effect? What are the causes regarding it, behind this? Why this is the beneficial effect factor? So the increased temperature increases the decreases the viscosity of the cytoplasm, increase the enzymatic activity, and increase the concentration of the calcium. This is a explanation regarding the beneficial. Is it clear? आपके नंबर्स नोट किए? चेन्नई के देखिए स्टॉप शेयर करता है
एक बच्चे हैं
ओके पेपर के